Welcome, everyone. For today's prep, we're going to look a little bit more at infinite limits. So this is something we've done with looking at graphical limits and numerical limits, but now we're going to see that in most cases, or a lot of cases, it comes down to this C over 0 form. All right, so let's just remember, graphically, what do these infinite limits look like? So this is something we looked at when we were talking about graphical limits. And what can happen is, in this case, we said that right around x equals 2, our function is getting higher and higher up on the page. And in this case, we said that the limit of this function as x approaches 2 was plus infinity. And we can see that the height of our function in this case is getting large positive as we move closer to 2 in either direction. So the left side it's going up and up and up, and then on the right side, the graph is going up and up and up. So we can have something like this where it's large positive. We can also have large negative. So, we might have something where the function is kind of going down like this, going to minus infinity. We've also seen this when we looked at numerical limits. So we've seen cases where if we are trying to do the limit as x approaches, say, 1 from the left of some function f of x, well, numerically, what we would do is we'd pick values that are getting closer to 1, but slightly smaller in this case. And what you would see if we had a limit that was going to minus infinity is you would see the corresponding function values getting larger and larger negative. And if it was going to positive infinity, well, then we'd see function values that are getting larger and larger positive. So the notation we're using is this plus infinity or minus infinity, depending on if the numbers are getting bigger positive or getting bigger negative. So that's our definition of the notation here. We say that the limit of f of x as x approaches a is equal to positive infinity if the output of our function, the values are getting larger and larger positive, and then minus infinity if they're getting very large negative. So it's just important to keep in mind, infinity, the infinity symbol is not a number, so we can't do regular arithmetic with it. So we kind of have to just treat this almost as like a destination. So our function's going off to this far off place, infinity or minus infinity. You want to think of it not so much as a number, but almost as like a destination. So technically speaking, if a limit is infinite, it doesn't exist. So in order for a limit to exist, it has to be equal to an actual number. So technically, if the limit of a function is equal to infinity, the limit really doesn't exist, but it doesn't exist in a very specific way. So we want to actually, make special note of what's going on. So we do want to use plus infinity and minus infinity, even though they're not technically numbers. All right, so how do we locate an infinite limit? Well, this usually happens when we have division. And what happens in our function around one of these places where we have an infinite limit is we are attempting to divide a non-zero number by 0. So an infinite limit usually happens when we have a non-zero number, call that c, and we're attempting to divide that by 0. So we're going to call this the c over 0 form. So when we have a function and we're trying to do a limit, our strategy here is to first identify that we do actually have a c over 0 form. So the first thing is, we'll just plug in the number x is approaching and see what you get. And if you end up with a c over 0 form, what that's going to tell us is that's actually going to tell us the limit is either going to be plus infinity or minus infinity. And well, it's up to us to figure out which. And what we're going to do is we're going to use a test number to determine, is it positive or negative? So let's try this out in an example. we're going to look at example 1, and we're going to look at this first part here. So we have this function 1 plus x over 4 minus x, and we're doing the limit as x approaches 4 from the left. So a little bit smaller here. All right, so whenever we're presented with a limit like this, where we have the formula for our function, and x is approaching a specific number, the first thing we should do is just, well, plug the number x is approaching into the function and see what you get. If you get a number that makes sense, well, then that's your limit by continuity. But let's see what we get here. So when I plug 4 in, actually I want to save that. So let's plug 4 into our function. What do we get? Well, we get 1 plus 4, so we're going to get 5 on top, and then we get 4 minus 4 in the bottom, so we get 5 over 0. So the first thing we need to do is just identify that when we kind of go with our first strategy for doing limits, we end up with, in this case, a c over 0 form. So that's kind of the first thing. We just try our regular plug-in direct evaluation strategy, but in this case, we end up with a c over 0 form. So what that tells us is this limit is either going to be plus infinity or minus infinity. So it really tells us that we have an infinite limit that we have to deal with. And we just have to decide, is it going to be positive or is it going to be negative? And the way we make that decision is by using a test number. So let me move this up a little bit. So step 3 then is to actually use a test number to figure out if the values are positive or negative. So in our case, x is approaching 4 from the left. So we want to pick a number that's close to 4, but just slightly smaller. So in our case, maybe let's pick test number 3.9. So it's close to 4, but just a little bit smaller. And what we're going to do is we're going to plug this in to the function. So we have our function here. We're going to plug in our test number. And when we do that, we get 1 plus 3.9 over 4 minus 3.9. And we don't really care about what this number is exactly. We just want to know, is it positive or negative? So in the numerator here, we get 4.9, a positive number. And then in the denominator here, we get, if we do the subtraction, we get positive 0.1. So, you could try to simplify this down, but really the main thing here is we have a positive number divided by a positive number. This thing is positive. So what that tells us then is we had two choices for what this infinite limit's going to be, and we found that the values are positive, so it must be positive infinity. So that's our limit here. So that's the idea. First step is identify that you actually have a c over 0 form. So I do want to see that as part of your work. Second step is just recognize what that c over 0 form actually means. It means the limit's going to be infinite, and there's two possibilities, either plus infinity or minus infinity. And then the third step is to pick a test number that's kind of close to the number you're approaching, plug it in, and see if you get a positive or a negative value. And then that tells you which of these to pick. So let's try this again. Same function, but now we're going to be approaching from the right-hand side. So x is going to be approaching from the right. So let's, again, first step, we want to show that we have a c over 0 form. Let's just pretend that this is a brand new problem here. So what we would do is we'd take, in this case, x equals 4, and the number x is approaching, and we just plug it into the function. This is usually our first strategy on calculating a limit. So when we go to calculate a limit, we look at the we identify the number x is approaching, so 4, and we just try plugging it in. If we get a number that makes sense, then we're done. That's our limit by continuity. But if we don't get a number that makes sense, well, then we're doing a little bit more work now. And we're seeing that for C over 0 forms, we end up with an infinite limit. So again, let's pretend this is a brand new problem we're doing. So when we plug in x equals 4, we're going to end up with 1 plus 4 over 4 minus 4, which is, again, that C over 0 form. In this case, 5 over 0. All right, so then we just want to recognize what this means. So it means that we have an infinite limit. And there's only two choices, plus infinity or minus infinity, for what the value of the limit could be. So then the last step, step 3, is to pick a test number and see, are the values of your function positive or negative? So in this case, x is approaching 4 from the right. So our test number here should be close to 4, but now a little bit bigger. So add a little bit extra. So maybe 4.1. And then we plug this back into the function. So what do we get when we plug that in? Well, we get 1 plus 4.1 divided by 4 minus 4.1. Try to simplify as much as you can. So 1 plus 4.1 is just 5.1. And then in the denominator here, 4 minus 4.1 is negative 0.1. And if we kind of look at this, what we have, again, we don't really care about the exact value here. We just want to know, is it positive or negative? So what we got is a positive number divided by a negative number. So positive divided by negative. And that means this whole thing is negative. The result here is negative. So that tells us then which of these to choose. In this case, minus infinity. Okay, so that's for the right-hand limit. We've done the left-hand limit. And if we wanted to consider, well, what's the overall limit doing for this function as x gets closer to 4, we just want to compare the left and right sides. So what we found is that our left-hand limit was going to plus infinity, and the right-hand limit was going to minus infinity. So because these are kind of going in two different directions, in our case here, we say that the limit does not exist. And we can just say the left-hand behavior does not equal the right-hand behavior. So because the two different sides of our function are going in different directions, we just say DNE. All right, so that's really the idea with these infinite limits in C over 0 forms. So in class, we're going to look at how this relates to this graphical idea of vertical asymptotes, and then we'll try one more example involving a trig function. So things to look forward to. We'll see you tomorrow. Bye-bye.